Hello my dear students, today we are going to talk about acids and bases. So in our previous session we talked about solutions, so this will be a beginning for our subject. This was a beginning for our unit, and now we will move on to the acids and bases, and this lesson is actually also related with the solutions that we learned yesterday. So for beginning, let's try to remember what are these acids and bases, and if we know some of them, some examples of them. So look at these breakfasts. How can it be related with acids and bases? Basically, actually, even though you probably didn't realize it, but we have these substances a lot inside our daily life, because what we eat or what we are made up of inside our body can be an acid or base. For example, the eggs that you are eating in your breakfast are basically containing bases. On the other hand, this orange juice, for example, you can see here, is containing acids. And your body also has some acids or bases. For example, your blood is an example for base. On the other hand, the saliva in your mouth is an example for an acid. Also, you have acids in your stomach, for example, to just digest some food. But we are using bases in our cleaning products like shampoo or window cleaners, or just any type of detergent. So basically what you can understand from this point is we are using these acids or bases inside our daily life a lot. And for the simplest definition, acids and bases are chemicals that increase the number of ions present in water solution. So that's why we learned solutions before. So now you know what a solution is. So we can understand if something is acid or base by just looking at their solutions. Okay? So we will dig deeper about this definition, don't worry. Lemon juice and vinegar can be an example for acid. On the other hand, shampoo or window cleaner can be an example for base. So, what is up with this water molecule? We will learn now. In chemical reactions, we see that water is made up of hydrogen and oxygen atoms, right? So, basically, this representation here, how the one water molecule looks like. So, what you drink, for example, in your glass right now, made up of these water molecules, millions of these molecules. But sometimes these water molecules can form these hydronium and hydroxide ions. Okay? Even though just a free regular water can have this hydronium and hydroxide ions. But what is special with acids or bases are acids can increase the number of hydronium ions. On the other hand, bases can increase the number of hydroxide ions when they dissolve in water. So how it is happening? Basically, the water molecules can break apart, okay, and they can leave one hydrogen, okay. So, and this extra hydrogen will be added to this new water molecule. So that's why you can see there is one excessive hydrogen here. It should be 2, but now it is 3. On the other hand, we have one missing hydrogen here. It should be 2, but now we have 1 oxygen, 1 hydrogen. But it is still water. It is just ionized. It is just break apart into ions. We call these guys ions because they have positive and negative charges. Okay? And for some substances we have this ionization. And water is a special substance that it can have different ions inside of it. So, how acids or bases are related with this? Even in pure water, we have these hydroxide and hydronium ions. Okay, but when we add acid in the water, now things are getting changing. Because when an acid dissolves in water, it is increasing the amount of hydronium ions. For example, we have inside our stomach, this is a representation of our stomach. Inside our stomach we have hydrochloric acid, okay, HCl, you can see here. When this hydrochloric acid dissolves in water, it is just this one hydrogen will form an hydronium ion with this water molecule. On the other hand, also it will leave this chlorine ion here, single here. So it will produce two different, one positive, one negative ions. Okay? If an acid basically in an acidic solution, you will see these hydronium ions. Okay? On the other hand, a base increases the amount. A base will increase the amount of hydroxide ions. See, here we have a sodium hydroxide base here, and it is showing us how it will dissolve in water. When this sodium hydroxide base, this substance dissolved in water, it will produce sodium and hydroxide ions. Okay? And because it will produce hydroxide ions inside the water, it will increase the amount of hydroxide ions. Okay? After dissolution. When sodium hydroxide added to the water, we will see these breaking apart and forming sodium and hydroxide ionization. So if we are observing that these number of hydroxide ions are increasing, we can say that, but we are observing this substance that we are observing is a base. Okay? So in simplest terms, you can say that an acid will increase the number of positively charged hydronium ions. On the other hand, a base will increase the number of negatively charged hydroxide ions. In hydronium ions, we have 3 hydrogen, 1 oxygen, but in hydroxide ions, we have 1 oxygen and 1 hydrogen. We also have a really good image from your book here. So in water, when we add hydrochloric acid or HCl, if you can remember it like this better. So we are adding hydrochloric acid, and it is asking for us to show the hydronium ions and chlorine ions. So these guys, these green particles here, are showing the chlorine ions. On the other hand, if we are seeing 3 hydrogen and 1 oxygen, it means that they are the hydronium ions. So the number of hydronium ions, if you count these, you will see that the number of hydronium ions are higher than the number of hydroxide ions. Okay? one hydrogen, one oxygen. Or if we dissolve a base, sodium hydroxide, this sodium hydroxide solution will have more hydroxide ions than the hydronium ions, okay? And it will also have sodium ions. For this lesson, lastly, we will learn some about strong and weak acid and bases. So we have this strength also in acids and bases, and it depends on how many ions are formed in a solution of an acid or base. So imagine what we said about acids, they should increase the number of hydronium ions. So if an acid is strong, it will increase the hydronium ions more than these weak acids. And same is true for the bases. If a base is strong, it will increase more these hydroxide ions. So let's see some examples to make it more clear. Here we have vinegar, for example. It's a weak acid, and when weak acids dissolve in water, they will produce less amount of hydronium ions. Okay, so most of these molecules of acid will stay same. Here what is happening, actually this molecule from the molecule of vinegar, one hydrogen atom is going to the water molecule to form hydronium ion, okay, this positive charged ion. But if it's a strong acid, this ionization happens more. But if it's a weak acid like this, so only some molecules will break apart, okay? But most of the molecules of acid will stay the same, will remain the same, like as CH3COOH, but as their original chemical formula, okay? But normally, in order to increase the hydronium ions, they should change into these negatively charged particles, okay? So, for example, in strong acids like hydrochloric acid, it will form a lot of hydronium ions. Almost all of these hydrochloric acid molecules will dissolve in water, will ionize inside the water, and will create as much as hydronium ions as they can. So that's why we call them strong or weak, okay? For example, we have also this for bases. Ammonia, for example, it's a weak base, and what is happening with bases, remember, they are creating hydroxide ions like this, and basically these ammonia will take one hydrogen atom from the water molecule, and it will form hydroxide ion, and also it will form this NH4 positively charged ion. So basically in weak bases we don't even see the hydroxide ion inside the formula, okay? See the beginning of what was it, NH3, we can't even see the hydroxide ion here. It is taking one hydrogen from here and making this water molecule, turning this water molecule into hydroxide. On the other hand, if we are talking about a strong base like sodium hydroxide, for example, it already includes an hydroxide ion inside their formula. Okay, that's why when they dissolve in water, they can immediately produce hydroxide ions in the solution. Okay, and that's why we call them strong bases, because they will increase the number of hydroxide ions more than the substance ammonia that we see here. Okay, so basically if an acid can increase the hydronium ions more, we are calling this a strong acid. If it is not that much successful for increasing the hydronium ions, we call them weak acid. And the same is correct for bases. If a base can increase the number of hydroxide ions, we call them strong base. If it is not that much successful for this job, we call them weak. So basically their jobs are increasing these ions. So if they are successful, they are strong. If they are not that much successful for this job, we call them weak. And this weakness is not related with concentration. Also, please remember this. We can't say that if we put more hydrochloric acid, or I'm sorry, if we put more vinegar into a water, we can make it a strong acid. No. This is not related with concentration. Okay? It is not determining the strength of the acid or bases. Okay, it can be concentrated or dilute. It can contain a lot of base or a small amount of base. Still, if we are dealing with a strong base, it will act more, it will show acidic or basic properties more. Okay? Here there is another representation may help you to understand it better. It is we have a strong acid inside the water and we see full ionization, and again we have a strong base inside the water and we see again full ionization. On the other hand, when we put weak acid or weak base, we can see this full ionization. Some of these particles are ionized, but not all of them, also with the same with the weak base. So that's all for today for acids and bases. Tomorrow we will going to talk about these more. If you want to check what we learned today, please open Module H, Unit 5, Lesson 2, and pages between 278 and 280 will help you to cover this unit and just see the examples, different examples if you want, and see you in the next session. Thank you for listening.